In terms of the coordinates on the unit circle, tell me what you know about sine. It's got something to do with the coordinates. It's y, so really the equation is y squared plus x squared equals 1. That's the equation of a circle, and you just change the radius by changing this value. So we want a radius of 1 because it's unit circle. If you wanted to graph, for some reason, a radius of 2, this would become a 4. If you wanted to graph a radius of 3, it would become a 9. It's just how circles work. You don't need to know all that, but that's where it's coming from. Let's put that on the back of our formula. This is going to be our very first formula for today that says sine squared plus cos squared equals 1. And coincidentally, I don't know, is the blue poster fell off last night, and I found it on the floor, and it's the one we're going to talk about today. So I feel like he just wanted to be front and center. That's our first formula on the top, sine squared plus cos squared equals 1. Let's isolate sine squared. Why? Because we can. Let's get this sine squared all by himself. How would I get rid of plus cos squared? I would minus, and I'm going to put it behind the 1. So I can say that sine squared by itself is 1 minus cos squared. Same formula, I've just changed around where the terms are. Let's add that one underneath, because he'll become important in a second. Well, that was fun, but let's go back to the original equation and let's get cos squared by itself. Why? Just for fun. So if I wanted this cos squared by itself, what would I do with this sine squared? Minus it, and I'm going to stick him behind the 1 as well. And let's add that to our card. Are these on the formula sheet? She asks, like she doesn't already know the question or the answer to that.
Yes,
all of them?
All of
them. Yeah, this one is on there. These are assumed to be known because they expect in your head you can just isolate one of the variables. I just put them on the card so that they're in front of us. But it's all the same formula. I just took the first one and just rearranged it. I'll tell you in a second why we need it. We're just practicing getting the formulas. Well, now let's go back to the original, and let's divide by sine squared. Why? Just because I can, and it's kind of fun. So I'm just going to divide every single term and both sides by sine squared. And mathematically, I can do that as long as I do it to both sides. And let's just simplify and see what's going to happen. So what happens with sine squared divided by sine squared? Okay, so that's kind of handy as I end up getting a 1. What about cos squared divided by sine squared? If I took the sines or the squareds away for a second and I just said cos theta divided by sine theta. So flip your card to the front. And is there a formula we've already talked about that's cos over sine? Okay, so cotan. So I can throw the squareds on there, and I say that this is cotan squared. Okay, 1 minus sine squared. If I take away that squared for a second, say 1 minus sine. Is there a formula on the front that we've talked about that's equal to 1 over sine? Cosecant. So I can make that cosecant squared. And what that gives us is a second formula that's really the same as the first formula. It just looks different. So I'm going to put him on the right-hand side of my sheet. And let's take him and let's get cotangent squared by itself, just in case we need that, because we've got cosecant by itself, but let's do cotan. And so what would I have to do to this 1? Minus it. We tend to put him in the back, so we can say that this is cosecant squared minus 1. So again, it's all the same formula. We're just playing around with what it looks like. And let's go back to the original, and we'll do the same thing now, but we'll divide by cos squared. So go back to our sine squared plus cos squared equals 1. And this time I'm going to divide both sides by cos squared. And so if we go term by term, if I take away the squareds for a second and I say sine divide by cos, sine divide by cos is tan. So what's sine squared divided by cos squared? Tan squared. And cos squared divided by itself is 1. And if I take away the squareds and I just say 1 over cos, that's secant. So 1 over cos squared has to be secant squared. Again, same formula. I've just changed what it looks like. And so let's add that one just underneath. Tan squared theta plus 1 equals secant squared theta. And let's isolate tan squared, just in case we need it later. So what would I do with that plus 1? Would take them over to the other side. So what would that give us? So if you look back to our blue sheet that fell off the wall that I will put back, these are called the Pythagorean formulas, or Pythagorean formulas. What's Pythagorean theorem? A squared plus b squared equals c squared. Well, that's what this is. This is x squared plus y squared equals 1 squared. So these all come just from Pythagorean. Look how much he knew way back 6,000 years ago. So that's the first one, this is the second one, and this is the third one. Those are on your formula sheet. The rearrangements are not, but you can use your card too. I want you to make a note somewhere on the front and the back of your card. If we go back to the front, which I lost mine, I know, shameful, we can square the fronts and they are still true. So you might want to make a note somewhere, these still work if we square them. So we can take anything on the front and we can add the squares and it's still going to be true the left-hand side to the right-hand side. We can square them and they're still true. So anything on the front can be squared. So I can say that sine squared is 1 over cosecant squared. Cotangent squared is 1 over tan squared. I can do anything I want to the front. I can square it all, and it's good. The problem with the back is I cannot take away the squareds. It doesn't work that way. So they don't work without the squareds. So I cannot say that sine plus cos equals 1. I can't say that 1 plus cotan is cosecant. I can't say tan plus 1 is secant. They don't work without the squareds. None of them. None of them work on the back without the squareds. The front, I can square anything I want. I can't take away the squareds from the back. They're not true without the squareds. So this is the theory behind why these formulas are here and why they exist. What's their purpose? We'll take a look now at the examples that we're going to do. We're still doing trig equations, same thing from yesterday. We're still going to use the same steps. It's just now we've got a secant and a tan in the same question. We've got a secant and a cos. We've got a secant, a sine, and a cos. We've got a cos and a sine. And so these are the formulas we're going to use in order to rearrange what different stuff look like. So what I called these was solving trig equations with more than one function, because there's more than one function in each question. You probably didn't notice, but if you look back to yesterday, they only had one function in every single one of them. They were all cos or all sine or all tan. Now we're mixing and matching. So the deal is going to be your card. That's why this card is going to become very useful, and use it as a bookmark because you don't want to lose it. So example number 1 going to be the same steps as yesterday. The first thing I do with any kind of trig function is I highlight the interval. And the reason I do that is because I want to make note if it's not there. And what's going to happen is you're not going to notice when it's not there because it's missing and your eyes aren't going to see it. Or if you get in the habit of always highlighting it, when you go to highlight and it's not there, that's going to twig into your head, wait a second, no interval. The exam always has a trig equation. It usually has one that has no interval because they want to know if you're paying attention to that. So get in the highlight, just always highlight that interval because then if it's not there, you're going to pause and go, wait a second, there's nothing there. So what you did yesterday is you got the trig function by itself. The problem is there's two. So what do I do? Well, this is when you grab your card. And you're looking for some kind of formula that's going to link secant to tan. So I always start on the front first. And I look, is there anything on there that has in the same formula secant and tan? Okay, which formula on the front has secant and tan in the same formula? There isn't one. So now I flip to the back. Is there any kind of formula that's got secant and tan in it? Okay, so automatically I'm down in this section. We just need to figure out, am I replacing secant squared and putting tan squared plus 1? Or am I taking tan and putting something else in? Well, these don't work without the squareds. You can't take away the squareds and say that they're true. So I cannot replace tan with anything because I can't say that tan equals secant minus 1. My only possibility is to take secant out and put in tan plus 1, squared plus 1. That's the way these questions are always going to work. I always start in the front. If there's a formula that links them, great. If there isn't, flip to the back. There's going to be a formula somewhere that we can replace. I'm just going to repeat, how do you know which one to replace? Well, it has to be the secant squared because I don't have something without tan squared. So all I'm going to do is I'm going to take that secant squared out. And I'm going to put in what's called the other half of his identity. These are called identities, which is our next unit, by the way. Secant squared is going to come out. What's the other half of its identity? Tan squared plus 1. These questions will always work this way. I go to the front of the card first. If there's a formula, use it. If there isn't one on the front, go to the back, figure out which one's going to work, swap it out. Now I have all one trig function. So this now is a question from yesterday. How did we do this yesterday? Isolate. So get everything onto one side. So I'm going to move that 2 tan over. So I'm going to keep my tan squared. I'm going to minus 2 tan theta plus 1 equals 0. Now if your brain is like, that's a lot of stuff, I don't know what I'm doing, on a scrap piece of paper. So off to the side, not on this paper on your exam, on scrap paper, put X's instead. Because your brain is used to seeing this, and your brain has factored this since grade 9. It's a lot nicer than trying to do this. If you need to do this, great. If you don't, great. Just don't do this on the paper without defining what X is. If you want to do it on the paper, we have to start with let X equal tan theta. As long as you have that statement, you can do it on the paper. That's why I say just do it on scrap and don't worry about it and then throw the scrap away when you're done. How do we factor this? Offer of -1, -1. Turn and talk and tell your partner why that's the correct factoring. Come back over here now, take out the X, put in your tan function. So how do we turn this back into tan? Tan theta minus 1 and tan theta minus 1. Let's backtrack a little bit. Did we have to factor? How many ways are there to solve a quadratic? What are the 4 ways to solve a quadratic? Factoring, complete the square, quadratic formula, square root. Square root is the formula. Do we have to factor? No. Pick any one of those methods you want. You could quad formula this if you want to. Do it any way you want. What do we do now that we've chosen to factor and we have factored? Do I need to do both of these? Why not? Because they're identical. We're now down to isolate the trig function. We have done that. Step 2 is reference angle. This is our 5 values of tan that we've memorized. You've got to think, what's the family that has a tan value of 1? What quadrants are we dealing with here? Okay, where do we find that information in the question, first of all, and then let's come to consensus. This step right here is what tells us, because there's an imaginary plus sign. So if you need to draw the casserole, draw it. There's nothing wrong with that. What quadrants have a positive tan value? What is the pi on 4 family in quadrant 1? Which I'm so sad I missed pi day, by the way. Makes me sad. What's the pi on 4 family in quadrant 3? The very, very last step is check your interval. So you've got to come all the way back to the top and now ask yourself, are these valid answers, or do we need degrees, or do we need some negative coterminals, or do we need that funky notation? What do we need and how do we know? How do we know they're both good? Because this means every single quadrant. And in terms of a picture, it means from 0 all the way to 2 pi. So it means all 4 quadrants are valid. Are these valid answers? Yes, they are. There we go. The only thing that's different from the questions from Monday and Tuesday is we're starting off with 2 different trig functions in the same question. What do we do with them? We use something on this card. Don't make a face. No. Yeah. Not the exam. I don't care if you use it for a test or a quiz. I mean, as long as you don't add extra notes on it, but. Okay. Except me supervising the exam. Wait a second. They do. Wait till next unit. Next unit is the tree killer. What's the very first thing I do when I solve a trig equation? I go right here and I take note of that. And the minute I see a negative interval, what does that tell me? There's going to be some negative coterminal. So I write myself a note. Just so later when I come back to step 5, I've already considered the interval. What's going to happen is there will be no interval, so you will completely forget to look at it. And the fact you'll forget means you're going to lose a mark for not putting that funky notation. That's why the first thing I do is highlight it just to remind myself, okay, it's there. I'll come back to it at step 5. Step number 2, you look at the equation and say, are there 2 different trig functions? Yes. If there are, you're automatically grabbing a card. I start on the front side first. And I say, is there anything that's going to connect these 2 functions? Is there anything connecting secant to cos? What's the formula? So I could use tan, but that's going to start to get even messier. Is there a better one? Cos equals 1 over secant, which means secant equals 1 over cos. So I have a choice here. I can take the secant out and put 1 over cos, or I can take the cos out and put 1 over secant. It's completely up to you. But when you think back to the unit circle, what have we memorized easier, cos or secant? Cos. So I like to try to get cos or signs in here just to make it easier for me. So because I want to do that, I want to take the secant out. Again, this is one way. It's not the only way. I could choose to take the cos out. I just don't want to deal with secant later on. I want to get rid of him now. So I'm going to keep the 3. I'm just pushing him off to the side. And I'm putting some brackets here. I'm going to take secant out, and I'm going to put 1 over cos theta in. The formulas at the front are called reciprocal identities. That's what I've used is cos's reciprocal identity. Cos is 1 over secant, or secant is 1 over cos. Repeating, I didn't have to do that. I could have absolutely taken out the cos and put 1 over secant. It's just when I get down to the unit circle bit, now I've got to deal with secant, and I don't want to. I want to deal with cos because he's easier. Step number 1 is dealing with these brackets. So remember, there's imaginary 1 under the 3. How do I multiply those two fractions together? Top times top, bottom times bottom. So 3 times 1. And then people always go 3 times cos, and I'm like, no, no, not 3 times cos. 1 times cos is just cos. And then people freak when there's a cos on the bottom. I'm like, no, no, no. What's the opposite of dividing something by cos? So I'm going to multiply every piece by cos to get rid of that fraction. So on the left, I've got the cos divided by cos, which cancels, and it's just going to leave me 3. On the right, I've got cos times cos. And just be careful, where does that squared go? He tucks in between. Otherwise, it's theta squared, and we have not squared any thetas in here. And then I have minus 2 times cos would be minus 2 cos. Am I boring you here? Well, this is good stuff. This is like, I've been waiting all year for this. Which in my quadratic. How do I know this is quadratic? How many ways are to solve a quadratic? Which way would you like to use? And again, if your brain's like, then come over here and put it with x's, because you're so used to factoring with x's, your brain sees this as familiar. Your brain is like, over here. If you can do it with this, do it with that. There's nothing wrong with that. But do this off to the side on scrap paper and then throw it away when you're done. How do I factor this with the x's? Okay, so something has to be equal to 0. Heard like a really quiet 1 and negative 3. X. Okay, so bring it now over here, and let's use the same argument. Okay, and then this is scrap paper, so I throw that away. Now what? Offer of negative 1 and 3. Okay. This is an axis value, so picture the little unit circle. X coordinate minus 1. It's got to be over here, so theta has to equal. Okay, there's no quadrants because it's right on the axes. What do I do here? Is it a unit circle value? Is there anything you've memorized on the unit circle that has an x coordinate of 3? Okay, so what's our backup plan if we can't do it with the unit circle? Okay, so grab your calculators. How do we do this on our calculators? Inverse cos 3. Make sure you're in rads. Have I shown you how to convert to, or somebody show you how to convert to rads if you're in degrees? Okay. Yep. And then usually during the exam, someone panically waves me over and says, my calculator's broken. I'm like, it's not your calculator. No, it's broken. No, it's not. So let's think about this. This would actually not be a calc question, so you wouldn't have the option on the exam to grab your calc. What is the biggest radius of the unit circle? 1. So the biggest possible cos value we can have is 1. Can it be bigger than 1? No, it cannot be bigger than 1. Let's go way back to when we did trig graphs in Unit 1. Remember we had that sine wave? What was the maximum value that it went up to on the y-axis? 1, because of the unit circle. You just didn't know it then. Did it go ever bigger than 1? No. Let's go back to grade 10 with our SOHCAHTOA. Cos is O over H. What do you know about H? It's the hypotenuse. And what's the definition of the hypotenuse? It is the longest side. So no matter what the triangle looks like, you're always dividing a small value by a big value. Can that ever be bigger than 1? No, this is undefined. And what's going to happen in exam panic is you're going to get here and think you need your calculator and think we are screwing you on the exam. We are not. There are no trick questions. There are never a question when you need one and they haven't given it to you. There's obviously something else. So make yourself a note. Cos cannot be bigger than 1. Sine cannot be bigger than 1. What about tan? Is root 3 bigger than 1? Well, sure you do, because what's root 1? And what's root 4? And so root 3 has to be in between. So go back to the little definition from grade 10 of tan. What's the two little sides that tan is used to calculate? O and A. Does it matter which one is bigger? So could I divide, in theory, a bigger number by a smaller number? So tan is not going to work this way. It's only sine and cos. Sine and cos cannot be bigger than 1. Sine and cos cannot be bigger than 1. So either by the unit circle, or by the graph, or by those formulas from grade 10. Whichever way you think about it, it can never, ever, ever be bigger than 1. So if you get sine or cos bigger than 1, cross it off. It doesn't work. Tan can work, cotan can work, secant can work, and cosecant can work. And we'll talk about those later. It's only sine and cos. Questions so far? We're not done. Even though we think, well, we've solved everything, we're done. We're not done. Why not? We got to always go back and check the interval. What do we do? So I always kind of split this into my head, and the way I look at it is that we can go from negative pi to 0 and then 0 to pi. And so this is quadrants 1 and 2. Anything within quadrants 1 and 2, this is the negative coterminal of those. So does pi count? Does it include pi or not include pi? It includes pi, so that tells you we need to find the negative coterminal of pi. How do we find the negative coterminal of any angle? Oh, thank you. How do we find the negative coterminal of any angle? So theta minus 2 pi. And this is just in our heads we would do this, so we would need to do pi minus 2 pi. And pi minus 2 pi is? So it just means we have a second possible angle value, which is negative pi. Two possible values, pi and negative pi. The only time we use that is when there's no interval at all given in the question. So if you look down to number 3 and number 5, but not this one because there's an interval. Let's do some more. You have all day tomorrow to practice and all day Monday. We're just working on the examples today. So no rush, no panic. Very first thing I do is I highlight the empty space. Because what that does is puts in my head, wait, there's nothing there. And I know if there's nothing there at the end, I'm going to need that funky notation. So what I tend to do if I were writing your exam is I would put the notation here just to remind myself. So that later when I look back up, I'm like, oh yeah, funky notation, because there's no interval in the question. And again, what this means in English is all possible coterminal angles. From negative infinity all the way to infinity. First step after highlighting the interval is you ask yourself, how many trig functions do I have in the question? 2. I always start on the front of the card. Is there any formula there connecting sine and cos? Tan, but the problem here is do I have a sine over a cos? So that's not going to work for me because there's no way to get a sine over a cos. Okay, so flip it over. Is there anything on the back linking a sine squared or a cos squared? Why, yes, there is. So am I taking sine out or am I taking cos squared out? Why do I have to take the cos squared out? Because these don't work without the squareds. I cannot say that sine is 1 minus cos. It doesn't work that way. So the only thing I can do here is I can take this cos squared out. So I'm going to leave that sine squared that was there, and I'm going to leave that negative 3/4 on the other side. And all I'm doing is using the identity that cos squared is the same as 1 minus sine squared, called a Pythagorean identity. Okay, now I got all one trig function. I'm back to yesterday. What would you have done with this yesterday besides cried? Okay. How do you want to do that? No crying. There's no crying. Is it quadratic? How many ways are there to solve a quadratic? And what are the 4 ways? Which one would you like to use? You want to use complete the square? Tell you what, you do that. We'll do it a different way, and we'll see who gets there faster. You probably want to factor? Okay, if you want to factor, you probably don't want this fraction here. So how can we get rid of the fraction? If we don't want to deal with a fraction, don't. How can we clear it? Times everything by 4. So that's going to get rid of your fraction. So this is going to become... That was like numerical Tourette's there. We're good? We're good? Okay, now what? Yeah, and I probably don't want the squared to be negative, so we probably want to do some kind of work there. Everything to the other side, so you want a 0 on this side? Okay, so let's go in order. My negative 4 sine squared would become... My 4 sine would become... My 4 would become... But I already have a negative 3 there. Okie doke. Okay, if you don't want to factor, you don't have to. What's our backup plan if you don't want to factor? We could do quad formula. The problem is you're not going to have a calculator. So if quad formula requires you to need a calculator, then don't go with that method. It's completely up to you. I would still want to factor just so we could practice. This is fun, factoring. Again, I'm just going to put it like this because that's the way a lot of brains are used to seeing it. Good time to review. How do we factor when there's a stupid 4 in the front? Okay, so that's giving us a product of negative 28. What sum are we looking for? Negative 4 in the middle. So we got to find what's the numbers that multiply give us 28, add or subtract to give us negative 4. So 1 and 28, 2 and 14, okay, 3 and nothing, 4 and 7, 5 and nothing, 6 and I'm back to 7. What does that mean? That gives us 3 though, right, when we add them, so we can't, we need 4. Okay, let's just, maybe we missed one. 1 and 28. 2 and 14. 3 and nothing. 4 and 7. What does that mean? It means it's not factorable. Does that mean we can't solve it? No, it is a quad formula question. Not factorable doesn't mean it's not solvable. It just means we can't use that particular method. What method would you like to use if we can't do factoring? Okay, so I'm just going to work off this for quad formula rather than bringing the signs in, so let's go to here. Quad formula says x equals, without peeking over on the wall, can you remember quad formula? Negative b plus or minus b squared minus 4ac. It's on your formula sheet. It's up on the wall. You don't need to know it. That was just for fun. Okay, so negative b, negative 4 would be negative 4, 4. Negative 4 squared, 16. Negative 4 times 4 times negative 7. Might need a calculator for this one. Negative 4 times 4, 16, negative 16. Negative 16 times negative 7. I heard 112 with a question mark at the end. Anybody want to double check that? Okay, 2 times 4 on the bottom. Okay, now what do we do with this? Okay, simplified how? Okay, add under the root. Okay, now what? Yeah, now's the calculator. So I'm going to split the two answers. So x can be plus root 128 divided by 8, or 4 minus 128 divided by 8. Don't round off, but get the decimal value and just give me a couple. Can I put 1.914 dot, dot, dot? Somebody just confirm that answer. Negative 0.914 dot, 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 dot. Can someone confirm that one? And then last year we would have been done, but no, this is a trig question. So what we have is sine theta equals 1.914 dot, dot, dot. And sine theta equals negative 0.914 dot, dot, dot. So we still need to do reference angle, quadrants, and then talk about our interval. How do we find a reference angle? Yeah, is it a unit circle? Did we memorize anything with 1.914 blah, blah? So this is a unit circle question. Now think, 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 think.
No, it can't be over.
Can sine be bigger than 1? No, so you're going to put it in, you're going to get an error, and you're going to tell me your calculator's broken. I'm going to be like, no. So we don't need to do that side. We only need to do this side. Be careful on your calculator. Don't include the negative. The negative is not a value. What is that negative used for? It's just a quadrant. It's just the quadrant information. You need to drop it on your calculator. So you're doing second function sine, 0.914, blah, 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 blah. Usually we do 3 decimal places unless the question says otherwise. So 1.154 if we round. Now in your head, because we did degrees last year, you're going to think that number looks funny. But you need to think this is rads. And what's approximately 1 rad? 58 degrees. So this is 58 and a little bit. This is about 60 degrees. Is that a quadrant 1 value? So even though it looks so small, you got to remember you're thinking in rads here. Okay, quadrants. Sine is negative. how do we find a Q3 answer when it's not a unit circle value? And I don't know what's going on. No crying. We go back to the little rules from last year. Last year we know that quadrant 1 is the reference angle. Then we gave you a tiny little formula in here for quad 2. It was 180 minus the theta value, except we're in rads. So 180 comes out. This is pi minus the reference angle. Last year in Q3 it was 180 plus. Now it's going to be pi plus the reference angle. And in quadrant 4, 360 out, 2 pi minus the reference angle. Okay, so there's your little rules when you're using your calc and you're in rads. So the Q3 answer is going to be pi plus 1.154, and the Q4 is going to be 2 pi minus 1.154. Sam, pick up your calculator. Sorry, a little bit louder. Somebody want to confirm? 4.656. They were just afraid to say it, but they knew it over there. Sorry, a little bit louder. Did we do these backwards? Because that looks like a Q4 answer. 1 point, I missed it again. 988. So I'm just going to put arrows because that looks like Q2 or 3 and that looks like Q4. Just wanting confirmation on that. Okay, we didn't like this. Was this one here?
Well, not that formula, but that first, like the 2 pi.
Yeah. Yeah. Was this?
Was 5.129.
Okay. Was this one correct?
I don't know.
Okay, let's just double check that one. Let's just double check these, make sure these are good before we go on. Sam's nodding, a couple other nods here. Oh, but after all that, we're not done. Because what's the very, very last step? You got to go back up to the top. And so theta is 4.296, comma 5.129 plus Z. This was a 5-mark exam question, which is the most marks for any question on the exam. 5 marks for this one. That's like as crazy hard as they're going to get. But the last exam did have a quad formula question, so we practiced. You want to do one more today and leave the rest for tomorrow? Just one more? We can leave the rest for tomorrow if is your brain tapped out? Okay, I'm good.